In this example, we are going to be determining a loan balance on an installment loan. If you are partway through your installment loan and you want to know how much you still have yet to pay, you don't necessarily need an amortization schedule to be able to show you that. You can use the installment loan equation to be able to determine it. We just have to make some adjustments to that equation. So we're still going to be using the installment loan equation. That's P 1 plus R over N to the NT power. That's going to be equal to D times E, the effective rate, all over R over N. Now this problem states to determine a loan balance for a given pay period, we simply input the pay period in question. So that's what we're going to do. There is no need to construct an entire amortization schedule. Suppose after 2 years, that's 24 months, of payments on your new Chevy Malibu, you wanted to know the remaining balance, P. That's the principal. So if you recall from example 4, the Chevy Malibu, we had an initial loan of $28,313.38. The rate was 2.9%. It was compounded monthly, so the number of pay periods is 12. And it was a 5-year loan. And if you recall from this problem, we use this to determine the payments that would need to be made. And we determined that the payments, if you recall, were $507.50. But this time we're now in the middle of the loan. We want to know how much we still have yet to pay back. So again, we're going to go with E. We start with E. E is equal to 1 plus R over N times NT. Don't forget, this is a rate. So since it's a rate, we have to subtract 1. But we're going to make a couple of adjustments to E. So we have 1 plus R over N. That's 0.029 over 12. N, it's 12. But the time here, T, originally when we first found out what the payment was going to be for the $28,313.38, this was 5. We're now partway through. How far through are we? Well, it says suppose after 2 years, it's 24 months. So we still have 3 years yet to pay. So that's what I'm going to put in, 3. 3 years yet to pay. Or you can think of this as 36 months after 24 months have gone by. And then we subtract 1. So if you recall, this comes out to be 1.00241667, except instead of raising it to the 12 times 5, which is the 60th power, we now raise it to the 36th power, minus 1. So we do 1.00241667, raise that to the 36th power, and then subtract 1. So E is 0.09078232. Now we can go back to our installment loan, but we're going to be solving for P. This is what we started at. We want to know where we're at after 2 years of payments. So we're going to be solving for P. So this is going to be P. This right here, this rate, here it is right here, here it is right here, this is it again, and here it is right here, except it's got minus 1, so we'll just add 1 back in, 1.0907 8232. That's equal to D. We already determined what D is. We're paying $507.50 a month. Multiply that to E. That's this minus 1, or here it is right down here. And of course, we divide that by R over N. That's right here. And this is it right here. So now I'm going to plug all of this right into my calculator as you see it. $507.50 times 0.09078232. Then I'm going to divide that 0.0024167. So we have P times 1.0907 8232. That's going to be equal to 19,064. Don't forget we're going to use as many decimals as we can, so we'll leave the 2609. Of course, now using algebra, we'll divide both sides by 1.0907 8232. These will cancel. So P is going to be equal to, so I'm going to take this, here it is right here, and I'm just going to go divide. This way it saves me from having to type in a lot of stuff. And we'll do 1.0907 8232. So after 2 years of payments, how much is still needed to be paid off for the Chevy Malibu? $17,477.60. The same could have been found using an amortization schedule, except for the amortization schedule, you would have to have filled out 60 different slots. Here, we just cut right to it. And there you go.